Good day, grade 12s. Let me welcome everyone in our technical mathematics lesson for today. So I'm going to take you through trigonometry for this lesson. My name is Mr. Kosa. So as you can see on the screen, we'll be dealing with trigonometry today. Now, before we can proceed, I just want to highlight some of the things that, remember, trigonometry, it forms part of paper 2. It's one of the topic in paper 2 that contributes a lot of marks. So let us try our level best to practice more under trigonometry. And then let's proceed and see what we have under trigonometry. Under content, we have break down the trigonometry to our subtopics. Now, before we can go to them, you can see that trigonometry contributes 50 plus or minus 3 marks for paper 2. Right? Yeah, it's a lot of marks that you really need to have when you are dealing with paper 2. So please let us try our level best to prepare ourselves before we can go and write our trial exam and the final exam. Now, the subtopic and that falls under trigonometry is trig ratios, identities, and equations, and then the trig function, and the last is 2 and 3D problems. Now, my dear learners, if you remember very well, the first subtopic of trig ratio, identities, and equation, and the other one of trig function and 2D. It's just a prior knowledge to us. We have done them in grade 11. Remember, this year in grade 12, we only did 2D problems. So the rest was just a revision to us. But all those topic or subtopic, they are very important. They are very important. They also form part of that 50 plus or minus 3 marks. So really we need to go back and do a thorough revision before we can start with our trial examination. Now, but today's lesson, we are going to focus on trig ratios, identities, reduction, and equation. That is today's topic. So I'm going to take you through that now. Now let's proceed. The introduction, like I've said, that our focus today is mainly on trig ratios, the identities, reduction formula, and equations. So we are going to apply the trig ratios, the identities, reduction formula, and we're going to touch a little bit on equations, right? Now, after we have completed this presentation today, one should be able to apply trig ratios in solving right angle triangle in all 4 quadrants. And then you must be able to apply reduction to simplify, reduction formula to simplify, and solve trig equations. And the last point, you must be able to prove trigonometry by using what? Identities. Now, these 4 points, they are most important for today's lesson. So let us make sure that after this we go back and try to do a revision on them so that we master them before we can go and write our trial examination. All right, now let's move. All right, we are now having example 1, then we'll be focusing on example 1, which is the exam type of question for trigonometry. I mean trig ratios. So we'll be focusing on this one for today. Now, before we can go and read our question and answer the questions, I just want us to talk about this right angle triangle there. Let me take my pen here. Right now, if you can all see this right angle triangle here, right? You all see this right angle triangle there. Then we all know that since we have the angle on the side, then the side opposite to this angle is our opposite. Now, in this case, our opposite is going to be y, and then adjacent from O to this point here is our adjacent, so which is x, and then O to R is our hypotenuse, which is R, right? Which is R. Now, there is something that I also want to emphasize with you, is this R. Now, in every situation, or in some cases where you are being asked to calculate the value of R, this R, it will always be positive. Please bear that in mind, that the value of R, it will always be positive, unlike X and Y. So X and Y, it will depend on the quadrant. For instance, in this first quadrant, we can see both X and Y, they are what? They are positive. For instance, if let's say this diagram, it was on the second quadrant, we can see that in the second quadrant, X is negative. X is negative in this quadrant, and then Y is positive. So in this third quadrant, both of them, they are positive, I mean negative. X is negative, Y is negative, right? So hence I'm saying R, it will always be positive, but as for X and Y, its signs will change depending on the quadrant our terminal arm lies, right? Then we have the trig ratios. So we are going to use our trig ratios time and again when we're answering this question, right? So please let us make sure that we know these trig ratios by heart, right? So that it becomes very easy for us to answer questions. Okay, now let's go back to our question and then let us try to understand. Then from this scenario, we have in the diagram below, point T, which is -6 is to P, is a point on the Cartesian plane. OT, you can see this is O, this is O, this is T here, is equals to 10 units, and the angle that is formed by OT with the positive x-axis is theta. Determine the following. P. Now let us come to this diagram. Now, before we can start with answering that question of P, remember we will have to draw or construct a line like this so that it can be very clear to you that you are dealing with what? Right angle triangle, right? And then from O to T, we know that side is what? Is R. Ne? And then from O to this point here is the value of X. And in this case, the value of X is what? Is -6. Then from here up there is Y value. And then in this case, the Y value is P, right? And we will be going to calculate. We are going to calculate the value of P in this case. Now, in a right angle, if one side is unknown, then we all know that we are going to use what? Theorem of Pythagoras, right? From grade 9, grade 10, we all know that once you have you come across right angle triangle and one side is missing, you only have two, you just use what? Theorem of Pythagoras. So we are going to apply that in this problem. Now let's check the solution on how to answer that. All right. Now the first, you write the formula for Pythagoras, which is x squared plus y squared equals to r squared. This is the Pythagoras that you're going to use, right, in order to solve what? P. Then the second step, we just substitute. We have the x value there, which is -6. Here's the -6. Y value is there is P, and then R is 10. And then the last step, then we have what? Then you just press your calculator, you'll get 36 plus P squared equals to 100. Then you transpose that 36 to the right hand side. So then you'll have P squared equals to 100 minus 36. Now remember, we are not calculating P squared. We are in need of P. So we have to get rid of this exponent 2. So in this second from the last step, we are going to put square root in both sides. Once you put a square root in both sides, don't forget to put plus or minus. Don't forget to put plus or minus. Now our answer is going to be P equals to 8. Okay? Now, why do we have to ignore the negative? What happened to the negative? Now, look here. Now, if you remember P represents the value of Y. Okay? Now, we have to know in this quadrant, this is the second quadrant, we need to know in second quadrant, the value of Y is supposed to be positive or negative. So we all know that in the second quadrant, Y is always positive in the second quadrant. Hence, we have our value of P equals to 8, right? For instance, if our terminal arm, OT, it was on third quadrant, then our value of P will have been -8, right? But because our terminal arm OT is now on second quadrant, then our value of Y or P will be positive. All right. Now we can now go and answer number 2, which is 2 cos theta. Number 2 cos theta. If you understand and we know, you know the trig ratios, then it won't be difficult for you to answer this question of cos theta, right? So once you come across cos theta, you must know that cos theta equals to what? Equals to x over r. Here it is, we have it here, x over r, x over r, right? That is the trig ratio for cos. So now we are going to, since we have determined all the sides, then it's going to be easy for us to calculate what cos theta. And let's see. Here it is. Cos theta equals to x over r. Then we know from the diagram that we're having there, or x is -6, and divide by 10, which is our r is equals to 10. then you just press a calculator, then our final answer is -3/5. That is that. Now let's go to number 3. Number 3, we are having sine squared theta plus 4 tan theta, right? And then let's see what we have. Now we know the trig ratio for sine theta, right? Don't be bothered by this squared. Just remember, or just know your trig ratio for sine is y/r. Trig ratio for sine is y/r. Now in this case, it's y/r squared, or we squared that fraction, plus 4 tan theta. Trig ratio for tan theta is y/r. Now I just want us to come to this one. It was just a typing error here. Actually, it was not supposed to be hypotenuse, because tan theta equals to opposite over adjacent, not hypotenuse. It was just a typing error there. You can even see on this side we have y/x. Y is our opposite, x is our adjacent, right? All right, now let's see. Then after we have written this ratios, we are now going to substitute. We know the y value, we have the r value, we have the x value there. You just put everything, and you press your calculator, then you will get -4,693, right? That is that. So I hope you understand this question. Now let's see if we cannot get another example similar to this one. All right, we are now having example 2. It's the exam type of question for trig ratios. Now let us look at this question. Now we are no longer having what? We are no longer having that diagram. In this case, we don't have a diagram, but we still have to calculate using the trig ratios. Now let us see how are we going to answer this question. Given cos beta equals to negative square root of 7/4, for beta is the element of from 0 degrees to 180. Determine without the use of calculator the value of the following: tan beta sine squared beta plus cos squared beta. Right? Now, if you remember very well, you will always have two sides. You will always be given two sides and one unknown side in the diagram. So it's very difficult if we answer this question without us to draw the diagram first. We need to know in which quadrant our terminal arm lies. So we are going to utilize the information we are having in this case, and then even the restriction, so that we know our terminal arm is in which quadrant, right? Now, let's see the solution. We say we first have to draw our diagram in order to be able to calculate the unknown side. That is the most important thing. You have to plot or draw your diagram. Now you draw your Cartesian plane, and then based on this restriction, you say from 0 degrees to 180. Now when you move from 0 degrees to 180, then you have passed quadrant, the first quadrant and the second quadrant. Okay? Meaning our terminal arm is either it's going to be on the first quadrant or in the second quadrant, based on the restriction here. But only one quadrant is correct, right? Now, let's see what we have. Here is our diagram. Now we have constructed our our terminal arm in the second quadrant. The question is how, why? Now remember, I just explained about this restriction is from 0 degrees. It's from 0 degrees until 180. So we will be focusing on the first quadrant or the second quadrant. Now, how will you be able to see which quadrant to use? You come here. Then we have cos beta equals to what? Negative square root of 7 over 4. Now you should remember, or you should recall, that the trig ratio of cos beta is equals to x over r. X over r. And I did explain to you that r, it will always be positive. It's clear from this question here. This negative is not for what I mean for this 4, but it's for this square root of 7, right? And then we said it's x over r. Then our x is negative square root of what? 7, and r is 4. Now, you check quadrant 1, you check quadrant 2. Which quadrant you'll find our x be negative? It will be on the second quadrant. That's where our x is negative. So that's why you find that this terminal arm lies on the second quadrant, right? All right, I hope you understand. And then you will get a mark just to plot this terminal arm in a correct quadrant. You will get a mark for that during exam. All right, now after we have constructed our terminal arm, we can see that the unknown side is this one of y, and then the r value is 4, and the x value is negative square root of 7. So now, in order to calculate this y value or this side, then we are going to use what? Theorem of Pythagoras. You can see we have the formula that it says x squared plus y squared equals to r squared. That is the theorem of Pythagoras. So we're going to use that to calculate that unknown side. Step number 2, we then substitute the values that we are having there, and then we are now having the value of what? Y, which is positive 3. But first, after we have just substitute, you then press your calculator, you'll have 7 plus y squared equals to 16. You then transpose 7 to the right hand side because we are looking for y. Then we are now having y squared equals to 16 minus 7, right? And then remember, we are in need of y, not y squared. So we have to get rid of this exponent 2. So square both sides, square both sides. Don't forget to write plus or minus, right? Plus or minus. But our answer for y is positive 3. Why not negative 3? Is because of the quadrant. In that quadrant, our y is what? Is positive in this quadrant. Hence, we are having our y value as positive 3, right? Let's proceed. Now we are able to answer the question now. The first question was saying tan beta. So we know that the trig ratio for tan beta is equals to y over x. Y over x. Then since we are having the y value there, it's going to be easy for us to calculate this, which is 3 over negative square root of 7. That is the answer for tan beta. Let's proceed to the next. Then we are having sine squared beta plus cos squared beta. We know that the trig ratio for sine beta is y over r whole squared. The trig ratio for cos beta is x over r whole squared. Thereafter, this You just substitute the values, then you are now having your answer. Just press your calculator there. You just press your calculator. And please, we should also understand this. When you say without the use of calculator, it doesn't mean you can't use calculator at all completely, right? We do have use calculator, but in some cases, we are avoiding a person just to press a calculator from the question. That person will have the first step, and that in that step it will be your answer. So we try to avoid that. We want to see all the steps. We want to see all the steps before you reach to the final answer. But it does not mean that you don't use that calculator at all. You can use calculator. For instance, in these cases, when you are dealing with this one, you can use calculator, and get your answer there. Right? Okay. I hope I'm making sense. Now let's proceed to the next slide and see what we have. All right, example 1, the exam type of question for reduction formula and identity. Now we will be focusing on what? Reduction formula and identities. So we are going to simplify using a reduction formula and identities. Now, before we can go and answer this question here, I just want us to come on this one. On the right hand side, we have this. Now, this sine into 90 plus or minus theta, as well as cos into 90 plus theta. Those are co-functions or co-ratios, right? Then from here until down here, we have what? Reduction formula that we are using to simplify. And then here is the negative angles. These are negative angles. So we're just going to discuss them verbally so before we can go and answer that question, because I did not write the final answer for each of these. So now let us start. We are having sine into 90 plus theta. So it's equals to what? It's equals to cos theta. We are having sine into 90 minus theta. We are having what? Cos theta. Then we come to this one, of course, cos into 90 plus theta. And the answer is negative sine theta. But why negative in that one? Is because when you talk about 90 plus theta, 90 plus theta, it is in the second quadrant. Then our cos in that quadrant is negative. Hence, we are having negative sine theta. Then we have cos into 90 minus theta. Our answer is sine theta. And then we are done. We are now having the reduction formula, which is sine into 180 plus theta. The answer is negative sine theta because 180 plus theta, it is on the third quadrant. Then our sine is negative in that quadrant. Then we have sine into 180 minus theta. The answer is positive sine theta, which is second quadrant, and our sine is positive in that quadrant. Then we move to cos into 180 plus theta. Third quadrant, cos is negative. So our answer is going to be negative cos theta. Cos, again, cos into 180 minus theta. Which quadrant? Second quadrant. Cos is negative. So our answer is going to be negative cos theta. We move to tan into 180 plus theta. Which quadrant? Third quadrant. So our answer is positive tan theta because in the third quadrant our tan is positive. Then we have tan into 180 minus theta. Tan into 180 minus theta. Which quadrant? The second quadrant. How is tan? It's negative. So our answer is negative tan theta. Then sine into 360 plus theta. Sine into 360 plus theta. In which quadrant? First quadrant. Sine is positive in that quadrant. So our answer is positive sine theta. Then we say sine into 60 minus theta. Which quadrant? Fourth quadrant. And how is sine in fourth quadrant? Is negative. So our answer is negative sine theta. Then we go to cos. Cos into 360 plus theta. Cos into 360 plus theta. Which quadrant? First quadrant. How is cos? Is positive in that quadrant. So answer is positive cos theta. Then we're having cos into 360 minus theta. Cos into 360 minus theta. Which quadrant? Fourth quadrant. How is cos positive? Hence we are having positive cos theta. The last one, tan into 360 plus theta. Which quadrant? First quadrant. How is tan in the first quadrant? Positive. The answer is positive tan theta. Tan 360 minus theta. Which quadrant? Fourth quadrant. How is tan? Is negative in that quadrant. Then our answer is negative tan theta. Then we move to the negative angles. For instance, we're having sine into negative theta. The answer is negative sine theta. Cos into negative theta. The answer is positive cos theta. Tan into negative theta. The answer is equals to negative tan theta. Now the reason why is only cos, which is positive, is because remember when we count our angle, we normally move anti-clockwise, right? But now when the angle starts to become negative, it changed the direction. It's no longer moving anti-clockwise, but it is moving clockwise. Once it moves clockwise, then it's going to be on the fourth quadrant. And then when you look in the fourth quadrant, it's only cos, which is positive. That's why in this case, you'll find that cos is positive here, and both sine and tan, they are negative, right? I hope I'm making sense on that one. All right, let me just erase this, erase this, erase that, right? Erase this, erase this. Thank you very much. Let me take a pen again. All right, now let's go to answer the question. The question says simplify without the use of calculator as a single trigonometrical ratio. Now we can see we are having reductions here. Sine into 180 minus cos into 360 minus. We just spoke about those things. Then tan x is from the identity. Then we all know tan theta is equals to 1, right? Now let's see the solution. Then this is the question, the first step from the question. Now this is sine into 180 minus x. Sine into 180 minus 180 minus second quadrant. So how is sine is positive? Hence we are having positive sine x here. And then we have cos into 360 minus which quadrant? Fourth quadrant. How is cos is positive? Hence we are having positive cos x. Now because we are having now tan x here, then tan x equals to, from the identity, equals to sine x over cos x. And my dear learners, I will always advise you that every time when you come across tan x, tan theta, you must always change it. Always change, because it's a mark. Just to change this tan x to become sine x over cos x, it's a mark. So simple. Under this, you just, under trigonometry, you just change, simplify, get the answer. Change, simplify, get the answer. That's why it's very important to study your identities, you must know them. You must know all the reductions, reciprocals. You must know all those things because you are going to use them to simplify, to solve, to prove, right? Then now we have cos into 180 minus x. 180 minus which quadrant is second quadrant? Cos is what? Is negative. Hence we are having negative here. We are having negative cos x. Then the next step. Now the next step, if we can check here, this cos x and this cos x cancel each other there. Then we are left with sine x multiplied by sine x. It gives us what? It gives us this sine squared x. Then on the denominator we have cos x multiplied by negative cos x. It gives us negative cos x squared. Right? Then we are going to use the identity. We can now change what? 1 minus cos squared. We all know that 1 minus cos squared x is equals to sine squared x. So instead of this, we just write sine squared x. Then this and this one, they give us what? Positive 1. Don't forget, change, simplify, get the answer. Because why? You'll be knowing your identities, reductions, and everything that needs to be learned under trigonometry. Let's proceed. We have another example where we are going to apply the reduction formula. Let's see the solution. The first step now, this is what? Sec x. Instead of sec x, we are now having what? We are having 1 over cos x. Reciprocal. Sec x equals to 1 over cos x. You get a mark for that. Just to change it from sec x to 1 over cos x is a mark. Then this one reduction, cos into 360 minus, it gives us positive cos x. Now look at this one, say tan squared into this. So this one, we did try to rearrange it like this. And then so that we can be able to see that, oh, we are having tan into 180 plus, right? And then we have cos squared x, we can leave it the way it is. Sine squared x, just leave it the way it is. All right, now we are now having 1 here. How? This cos x and this cos x cancel each other. Then we are left with 1 minus, then tan into 180 plus x. Third quadrant, our tan is positive. Then we'll now have what? Negative tan squared x times cos squared x all over sine squared x. Now, remember, I did advise you every time when you see tan like this, you change it. Here it is. Instead of tan squared x, you are now having what? Sine squared x cos squared x times cos squared x. And then all over sine squared x. Surely this cos squared x and this, they are going to cancel each other there. Let's see our answer there. Yes, they have cancelled each other. Then we are left with 1 minus sine squared x all over sine squared x is equals to, then they have changed this one. From the identity, we know 1 minus sine squared x equals to what? Cos squared x. Then cos squared x or over sine squared x equals to cot squared x. So that is our final answer on this one. I'm repeating. Change, simplify, get the answer. Change, simplify, get the answer. Because why? We know all the reduction, we know all the reciprocals, we know all the identities. Just apply them. All right. Now we have example 1 on trigonometry equations. Now let's see what we have. Determine the value of theta if theta is the element of 90 degrees to 360. If 2 cot theta negative 5 equals to 0. Let's see the solution. Our question. The second step, what you do, you have to transpose negative 5 to the right hand side. Remember, we are looking for theta in this case, right? And then we transpose 5 to the right hand side, and therefore we have to divide both sides by 2. Then we will now have cot theta equals to 5 over 2. And the fourth step, we have 1 over tan theta equals to 5 over 2. Reciprocal of what? Of cot theta equals to 1 over 2. Now, reason why we had to change this cot theta to become 1 over tan theta, because we will have to calculate this theta using a calculator. And when you look in our calculator, we don't have cot. We don't have cot. We can't get any value because we don't have cot. So we only have sine, cos, and tan. So we had to change this cot, right? Then from here, we are going to cross multiply. So after the cross multiply, we are going to obtain tan theta equals to 2 over 5. 2 over 5. Then you make the theta the subject of the formula. Then we're now going to obtain your reference angle. So this is going to be your reference angle, learners. This is your reference angle. It's not yet the answer. That is the reference angle that is going to help you to answer this question, right? And every time when you calculate the reference angle, then sometimes after comma, it will give you a lot of numbers. Just write everything as it is. Don't round off. You only round off when you reach the final answer. So please, my advice to you is that write everything. You'll only round off at the end of everything else, right? Now let's see what is going to happen with that reference angle. They say tan is positive in the first and the third quadrant. So we use the reference angle to find the value of theta, right? How did we pick up that tan is positive in which quadrant? From here, we can see from here that tan theta equals to positive what? 2 over 5. If it was negative here, then we'll only looking in which quadrant does this tan lies. You understand? So, but in this case, we can see that tan theta is positive because of it has equals to positive value, which is 2 over 5. So we are looking where the tan is positive. So the tan is positive in the first quadrant and the third quadrant. But we will only take the third quadrant. Why are we taking the third quadrant and not the first? Because we agreed that tan is positive in the first as well. Now, here is the reason. We are having restriction. You say from 90 degrees to 360, meaning if it's from 90 to 360, then the first quadrant is excluded, because from 90 to 360 is second quadrant, third quadrant, and fourth quadrant only. So based on this restriction, we have excluded the first quadrant. Hence, we are now focusing, we are now focusing on third quadrant only. Now, third quadrant, we know that in the third quadrant, we are having 180 plus. Now it's going to be 180 plus that reference angle. Then your answer is going to be this. So this is your answer. That is your answer. 201,801. That is that. Let's proceed. Example 2 is still, we're still on trigonometry equations. Solve theta for if theta is the element from 0 to 360 without the use of calculator. If 2 sine theta minus cos theta equals to 0. Now let's see on how to answer this question. The first step, we are going to transpose this cos theta. Now cos theta, now we are having 2 sine theta equals to cos theta. Second step, we are now dividing both sides by cos theta. So after we have divided, then we are having 2 sine theta divided by cos theta equals to 1, because they're going to cancel each other there. Then sine theta over cos theta equals to tan theta. We all know this from the identity. Sine theta divided by cos theta equals to tan theta. Now you're having 2 tan theta equals to 1. Then you're going to divide both sides with 2. Then we are now going to have tan theta equals to 1 half, right? Then we calculate our reference angle. We calculate our reference angle. Now our reference angle is 26,56505,118. You can press your calculator to check this answer. Now this is our reference angle that we are going to use to calculate this theta. Now tan is positive in the first quadrant. It's the first quadrant and the third quadrant. So we are going to use the reference angle to calculate the theta. Now first quadrant, in this case, you are now going to have first quadrant. Why? Because look at this restriction. You say from 0 to 360, meaning every quadrant is included. First quadrant, second quadrant, third quadrant, fourth quadrant is included, right? So hence we are now putting one. We are now having quadrant, first quadrant. Now in the first quadrant, we are having 26,565. Already our reference angle, it lies on the first quadrant. It's less than 90 there. And the third quadrant, we know the third quadrant we have 180 plus. Now it's going to be 180 plus the reference angle. Then our answer is 206,565. That is our final answer. Very simple, straightforward. You just have to understand all these things. Now we have example where you are going to prove using the identity. Then we are going to prove the left hand side equals to the left hand side equals to the right hand side, right? Now let us look into this question. Now before you start taking a side, because you have to pick one side that we're going to work with, so that we can make it to be equal to the other side. So you always take the complicated side, or the side that has more information. In this case, we can see that the left hand side has more information rather than this one of the right hand side. Now let's proceed and see. Now we agreed that we're going to take the left hand side. Then we did that. Then let's proceed. Now what we did here is cos squared x. So our cot squared x, squared x equals to what? Cos squared x over sine squared x. So we change this to this. We have changed cot squared x to become what? Cos squared x over sine squared x. Now we are having sec squared x. Sec squared x, according to the reciprocal, is equals to what? 1 over cos squared x minus, then we all know that sine squared x plus cos squared x equals to 1. Hence we're having 1 there. Then you can see, because it's a multiplication here, then we can just this and this one, you want to cancel each other there. The step, yes, because once they've cancelled each other, on the numerator we are left with 1, and the denominator we are left with what? Sine squared x. We are having this and equals to minus 1. Then we are going to look for LCD. Our LCD in this case is sine squared x, right? So we are going to say sine squared x into sine squared x is 1, and 1 times 1 is 1. Hence we're having 1 here. And then remember, if this is fraction, we were supposed to do a fraction as well here. We divide it by 1. 1 divided by 1. So that we say 1 into this, we are left with what? Sine squared x. Then sine squared x multiplied by negative 1, it gives us negative sine squared x. Then we have changed this. We have changed this 1 minus sine squared x to be cos squared x, right? Then our answer for this one is equals to cot squared x. This is our final answer. You see, that's why I'm saying you should learn all formula. You must learn identity, because you are going to use them throughout this topic, right? And the left hand side equals to the right hand side. All right, thank you very much. We are now having what the activity. You can take these questions and test yourself, practice with these questions, so that you can strengthen your understanding of this topic of trigonometry. This is my message for today, boys and girls. I hope you will be fine, and thank you very much for being with me.